We've been talking about this situation where to put a plant in a room so that the plant gets the least amount of light possible. Now, on my previous clip, I came up with the idea, let's figure out the amount of light the plant receives from just one of these light sources and then do the other and add it all up. So the distance to the lamp is going to be x. So I've got to have a fraction with the denominator x squared because the amount of light is inversely proportional to the square of the distance. And likewise, the amount of light received from the window will be some fraction divided by y squared, right? Because y is the distance to the window, x is the distance to the lamp. What are the numerators of these fractions going to be? Well, I know that I have to take into account the brightness. So I'll have a capital L over here for the brightness of the lamp. And the brightness of the window is 3 times the brightness of the lamp, so 3 times L. And finally, I'll need to take into account that these are proportional figures, even though my setup doesn't tell me exactly what the proportion is. So I will use the Greek letter alpha here to represent my proportionality constant, right? What is the multiplier you need to convert from brightness over distance squared into actual amount of light received? So this is the formula that I want to be minimizing for this problem. Now, sadly, I do need to get rid of these pictures to make a little bit more room. So let's clear that. Maybe just shrink that down and keep it off in the corner. There we go. So this is the formula that I want to minimize. And the problem that I see is there's a lot of letters running around in there. So how can I rewrite this formula in order to make it something I can actually work with? One thing that I noticed is that there are numbers here that are not going to change. And in fact, I don't have any control over anyway. So there's this constant alpha that shows up in 2 different places. And there's this constant capital L that shows up in 2 different places. So I just have this lamp, right? It's as bright as it is, and the window is 3 times brighter. I don't really have a way to control the brightness of the lamp. And I certainly don't have a way to control the brightness of the sun. So I don't actually get to control this constant here. And same for this alpha. This is coming from this inverse square law. The amount of light received is inversely proportional to the square of the distance. So instead of minimizing this formula, how about I minimize just the formula 1 divided by x squared plus 3 divided by y squared. And what's the justification for that is that whatever I do to minimize here, the only thing I can control anyway is the distance between the plant and the lamp, the distance between the plant and the wall. I don't get to control physics. I don't get to control the brightness of these 2 different objects. So all of my minimizing will have to be taking place inside these parentheses here. What I've done is I factored out this alpha, I factored out this capital L, and I don't have control over those things. They're both positive things. So any minimization I get to do will just be minimizing 1 divided by x squared plus 3 divided by y squared.